Welcome all. Today we'll see about option pricing, nothing but the Black-Scholes-Merton model. So it's one of the method for pricing options. So before going into this model, just to get a very good understanding and of what FRM or CFA expects, it's, even though there are mathematics involved or some calculations involved, so they like to test upon the logics. So if you're clear with the logics, I think this part is going to be very easy. So there are certain areas which they like to test upon. So say for example, if risk-free rate is increasing, what happens to the call option price, or if volatility is increasing, what happens to the option price. So by changing these variables, you should be able to understand or explain what happens to the option prices, how it impacts the models, and how it impacts the output from the model. So unless and until if you are not clear on this topic, I think you need to revisit this again, keep on again. So coming back, how we can simplify this. So as we all know, in case of Black-Scholes model, is a plug and play role. So even though I would say this model is predominantly used in most of the world stock markets, it's one of the greatest inventions, I would say, in case of derivatives for pricing. So it works like magic. So all you need to understand is, since FRM is all about derivatives, understanding Black-Scholes model gives you a very good grip on derivatives, friend. So coming back to the context, to price an option, we need predominantly 6 factors here. One is stock price, strike price, risk-free rate, time to maturity, and volatility. So stock price is nothing but the underlying price, and strike is nothing but the price at which you are going to exercise the option, and risk-free rate is the market interest rate, and T stands for time to maturity, I would say time till maturity of the option, and sigma here, the volatility is nothing but the volatility of the underlying. I mean to say, the volatility of the underlying, it is the volatility how the stock prices have moved, or it's an historical volatility. So that is one thing. And here stands for dividend, that is the dividend yield. If the underlying is paying dividends, what happens to the option prices? Say for example, here is the formula to price the option. This is the Black-Scholes formula. So they have taken, say the S predominantly stands for stock prices, as you know. X is strike price, and ND1, what does ND1 denotes here? ND1 and ND2 are two confusing factors among everyone. So understanding the logics predominantly helps. You don't need to mug up the formulas or something like that, but understanding what ND1 and ND2 will predominantly help. So ND1 and ND2, so these are basically standard cumulative distribution functions. Say for example, if I want to plot the stock in the normal distribution curve, say as I repeated earlier, the stock prices follow the normal distribution, and the log of the price change follows the normal distribution. So in this case, say for example, our stock price is somewhere around here, and our strike is here. Okay, so the strike price is the price at which we are going to exercise the option, and this is the price, the stock price actually. So ND2 predominantly helps in finding out the probability that our call option will be, I would say, in the money. So say for example, if our call option should be in the money, then our strike should be greater than, our strike should be less than the stock price. Agree? Our strike should be less than the stock price, then we call the probability that the call option will in the money. So the ND2 factors predominantly capture this zone. though this is the zone at which ND2 is arrived. So ND2 we already we also call it as the probability that the call option will be in the money. So in this case ND1, so since ND2 is the probability that the call option will be in the money, ND1 is nothing but it's simply if ND2 is 40%, the ND1 will be 60, right? 1 minus 40. So this is the probability of ND1. So in case of options, so what we are going to receive and what we are going to pay. So we are going to receive the stock. Say if we are exercising the option, we are going to receive the stock and we are going to pay the strike. Agree? So that's the reason. So we are finding out the differentials between these two. So now to keep it very simple, we'll see one by one what happens if the risk-free rate. So we know ND1 and ND2, we understand the basics. Why we are discounting this with the strike price with R and T. So the exercise price is the price at which we are going to exercise at maturity, or we are going to get the underlying at maturity for so and so price. So but what is the value of that strike today? Since we are valuing this option today, what is the value of this option today? If you want to value this option today, we need to discount the strike today. So for that discounting, we need market interest rate and then time to maturity. That is the basic time value of many concepts. We need market interest rate and time to maturity. So as we know, when the risk-free rate is increasing, when the denominator is increasing, we can see the value of the option and the time to maturity is increasing. Higher denominator value will translate into lower X value. Since we are finding the difference between stock and X, lower X value will predominantly increase the call option value, because we are subtracting with the lesser number. How to approach it in a logical way? Say for example, what happens if the market interest rate is increasing? Say for example, if you want to buy 100 stocks of Apple in the cash market, you need to pay 100 into 10, 100 into the quantity of 10, you need to pay $1,000. Before the cost of fund is 8%, that is the market interest rate is 8%. Now say for example, now it gone up to 16%. So previously it was $8, now it is $16. If you want to replicate the same position in options, as everyone knows, option you need to pay only the upfront premium, not the full amount, full exercise value. So in that case, instead of paying the entire delivery amount in the cash market, people prefer buying options. So what happens to option prices? If they are buying options, the call option prices will rise. So that is the logical explanation why call option prices rise when the market interest rate is increasing. And also the time to maturity, when you have longer time to maturity, as we can see in the graph, the stock price can move aggressively on this side or aggressively on this side. So the longer the time to maturity gives the option the higher value. Since say for example, this is the price of the option, the price can follow this direction and it can go up and it can come back to the same place again. So higher the time, I mean to say higher the time to maturity, higher the call option value. So what does this dividend yield do? Since in options we don't own the underlying, so we will not get any benefits from the stock. Say for example, if the stocks pay the dividend, if you are holding it in a cash market, we will be receiving the dividend, and the stock price, even though the stock price falls, will be compensated with dividend yield. But in case of options, since we are not owning the underlying, even though the stock price pays the dividend, we will not be getting the dividend. So the stock price will fall, but our we don't have dividends, so our option premium will fall. So predominantly, I will repeat again, it's the risk-free rate. So when risk-free rate is increasing, the option price will increasing, and time to maturity it increases, dividend it decreases. So what happens when volatility is increasing? So why volatility? As I repeated earlier, you can see when volatility is increasing. Say here the stock price is here at this zone. When the volatility of stock is say 50%, So the stock price can jump from one place to other place very soon. So your option can soon be out of the money or soon be in the money. You can see here, when the stock jumps, when the stock have the volatility of 50%, it jumps quickly to one place to other place. So this option is currently out of the money, but once it jumps to this place, it becomes in the money. So when volatility is high, higher volatility gives higher option value. So now just to reiterate again, because higher volatility, if say for example, if the volatility is 100%, say now the stock price is 100, tomorrow it can be 200 or it can be 0. So if you are owning a 150 strike, out of the money strike, if the volatility is 100%, so your option can still have a very good chance of being in the money. So that's the reason higher volatility translates higher option prices. So coming back to this thing, so if you're very good in these concepts, I think it will be a cakewalk. So just for our understanding, we'll know what these formulas mean. So D1, D2. So D1, as I said earlier, this part captures the jump to default. I would say, say for example, your strike price is 100 and stock is 150. So there is a 50% chance of jumping. So there is a 50% chance the stock price is at the jump to default region. So how we are going to translate this 15% to the normal distribution curve? So through the z-scores. As of now, I don't want to confuse you guys. If you're good with the logics, I think it is well and good. So what is our expected return? This is our expected return. Our expected return is reduced by the square root of variance proportionate by time. So this will be our expected return. Our standard deviation is this. So the D2 predominantly measures what is the probability that the call option will be in the money, and D1 predominantly measures what is the chance that is not in the money. It's more like what is the probability that you won't receive the stock. If the stock price is way higher than the strike price, so then say in case of call option, the stock price is way higher than the strike price, then the probability is very high that you will receive the underlying, because it's already deep in the money. Say for example, if the stock price is way less than the strike price, say if the strike price is 20, if the strike price is 100 and the stock price is 20, so there is the stock has to move $80 to reach 100, and then it has to move some $10 to become in the money. So there is a very less chance your option becomes in the money, and if you exercise it, you will get the underlying. So ND1 measures what is the probability that you won't exercise it or the option will not be in the money. ND2 measures what is the probability that it is in the money. So if you know the ND1 value, you can get the ND2 value. It's a simple subtraction. That's how it works. So hope you guys like it. So please comment if you have any doubts, and we'll try to address the option pricing, one more option pricing in the upcoming session. I think most probably the binomial models. Please share it to your friends too. It might be helpful for someone who is preparing, and keep tuned. Thank you for watching. Thanks.